In this video, I'm going to be going over a strategy for getting homework 4 done. What I have is your homework 4 sheet. Let's go ahead and delete those until you guys need them. Go ahead and look. So I have your homework 4 sheet. I'm just going to be walking through the answers. And I'm going to say how to do it, but I'm going to leave it up to you to do it programmatically yourself. So over on my other monitor, I'm just going to be essentially reading out what I did in sort of pseudocode. So let's go ahead and grab homework 4 here. I'll go to the top for you guys. Oh, whoops. Let's go ahead and transfer this. This is the key, by the way, if anyone wants to know what's going on there. Okay. So, what we have here is your homework 4. Now the first question you're going to be doing, and here I have an example what it looks like to read in a CSV, comma separated value. The first question that you're going to be doing is reading in a bunch of different file types. And maybe before we do that, let me go ahead and I don't think I can scoot this over anymore. Let's just zoom out a little bit for now. So you're going to look at a bunch of different file types, and I have a link here. You can click on that. If you hit Control and then click, you'll open it in your default browser. I want you to read in a CSV file, read in an XLSX file, that's an Excel file, a text file, a JSON file, an image, I use pyplot, and finally read in a data file. So bunch of files, the path is bunch of files. That's where these files are located. And feel free to inspect them. Open them up, look at them. So here, Excel opened this. You might recognize these values. They're XRD from your previous homework. We have our text file, where I just wrote random things that came to my mind. File.png, that cute little guy. File.json. It's tabulated data in dictionary format. File.data. This is data that's space separated. Spoiler alert. Pandas read CSV can do this if you tell it you want to delim with the white space. Google that. And then finally file.csv. So Excel can open it, but really you can open a lot of these with Notepad and see that it's just comma separated values. So easy to work with. You could parse this reading in it as a text file. You could parse it reading it in as a .csv. Up to you. Okay. Nice. All right. So that's this first part. You're going to this link. You're watching my video. You're figuring out how to use pandas for most of these to open up the file. Or pyplot. And in this case, Python has built-in ways of reading a text file. Okay, so now question 1. You've been given a folder named XRD data. This is the same XRD data you had on the previous homework. That's homework 3. But it's your job to combine all the XRD measurements together without screwing up like I did. Some of you noticed I had the 2 theta value multiple times, or rather in multiple columns in the last homework. Your job is to combine one together that doesn't have that issue. So let's go ahead and look at XRD data. Each of these has columns A through F, where this first column is the XRD 2 theta value. The rest are signals. I want you to combine this column with all the other signals in all of these files. So in your case, what that might look like is using OS to list out your directory. And so your directory, it's the path towards those XRD files, sort of like how path files gets this. The path to the XRD files is XRD data. So you're going to list out that directory. And then I'd make an empty data frame, like I did in the video where I explained pandas. And to that data frame, I'd iterate through each file. So I'd say for file in my list of CSVs and that XRD path, I'd first read in the file. I'd get the values that didn't have the 2 theta, and I'd concatenate them all together. And then finally, with my big old data frame, I'd do my pandas dataframe command .to_CSV, and I would save my CSV, probably without the header or without the index. And if you want to add a header, in fact, I think I tell you to, you'll be using the dataframe.columns equals column names command. Well, column names could be any variable name, but in that you should have some way of keeping track of what data sheet it came from and what column it was on. Alright, question 2. This is quite a bit more tricky. You're supposed to read in a MATLAB file, and you're supposed to save it as a NumPy compressed file. So essentially you have 3 MATLAB files. You'll read them in. You'll save those 3 vectors, or those 3 matrices, or tensors, rather. All 3 of those tensors will be saved to a single NumPy zip file, or using the savez compressed command, mp.savez compressed. Once that's saved, you'll then immediately read it back in. I know, silly, but you're going to do it. And you're going to load the objects, or those tensors you'd saved, into the appropriate variable names. And then I want you to tell me, because each of these tensors has the components of a vector, I want you to tell me how many vectors there are in this data set. So I'd recommend making a function called readMATLAB that takes in the location of the MATLAB file u.mat, the MATLAB file v.mat, and the MATLAB file w.mat. So those are 3 arguments your function will take in. And your function should return 3 arguments, u, v, and w, those being the vectors associated with, or rather the components associated with, a big list of vectors. So once you've done that, what you have access to are vectors that describe something a little interesting. Let me actually show you. Homework 4. They describe these vortices. So you'll have a bunch of vectors on this plane. Now a lot of these vectors have values of 0, but where they don't have 0, this is called a quiver plot, by the way. Arrows live in a quiver. Where they don't have values of 0, they'll have a direction. A u direction that spans the x-axis, so this would be like a negative u on that little guy there. A v direction that spans the y-axis, and a w direction that spans the z-axis. We're going to skip the w, or rather, we're going to look at slices along the z-axis. So this is x and y. And so in homework question 3, you're told these vectors lie evenly spaced on a grid. You just saw it. However, no absolute coordinates were provided. You don't know their xyz coordinates, so you will create them. So essentially you're going to build a function called GetGrid where you'll put in u and you'll put in v, and what you'll return are the x, y, z values associated with these vectors. So you've given it a component. In fact, let me just tell you, the shape of this thing, if I do u.shape, what I'll get from it is 40 by 40, but something like 120, where this tells me I have 40, a resolution of 40 on the x, a resolution of 40 on the y, and a resolution of 120 on the z. So what you need to do is create x, y, z coordinates with the same shapes that'll place these vectors in space. So GetGrid will take in either u or u and v, shouldn't really matter, you can get away with just one of them, and it'll return x, y, z values. For question 4, this one's fairly simple. If you've done the MATLAB part correctly and have generated UVW vectors, and if you've done the grid part correctly and have generated associated XYZ coordinates for those vectors, or rather the vectors whose components were U, V, W, and the vectors whose coordinates were XYZ, when you visualize it, you should be able to use the matplotlib Cuivre function. So with the Cuivre function, you'll give it a one-dimensional, or rather a two-dimensional slice of this three-dimensional volume. Now I might be able to dig around and find what this thing looks like. Let's see. So this is the three-dimensional version of it. You're going to grab one of these slices. And you're going to plot it. That's going to create a Cuivre plot that looks something like this. Doesn't have to look exactly like it, but you're going to have to print out one of these plots. Or rather, show one of these plots. Save it as a .png. So that's Q4. Now Q5, this is the difficult one. So Q5, given one of these plots, and there's a lot of them as you can see. Let's see. Given one of the plots, like this, for each slice, I want you to tell me if this little vortex center exists. And so what does that mean? Well, when you're done with Q5, you should create a list. And on that list, let's see. Yeah. On that list, you should have zeros and ones. 0 meaning there was no vortex, so this would be a 1. And 1s meaning there is a vortex in that slice. And so you'll look at every single slice from 0 to however many slices there are. And in your list, you'll give me a 0 or a 1, whether or not that slice has a vortex. So let me run this. And I had some fun. So I put either a green filter with a vortex or a red filter saying no vortex. And so you'll see the majority, in fact, are green. And I don't expect you to get it perfect, but I do want you to do a good job and have creative solutions. So 3 ways you can solve this, written in text, and then select one of them and code it. Once this is finished running, let me go ahead and make that a little bigger for you guys. I'll even stop it. Let's go ahead and look at one. So see how there is no swirl here. You want to compare and contrast, so you start to get that vortex right there and right there. And there's a vortex there. You want to compare and contrast these. And here's a little bit more pretty example of a vortex versus no vortex. So this sort of situation, that's ambiguous. I don't care if you get that right. But these two, you should be able to get that. So think of ways you might be able to do that. Think of linear algebra. Without giving too much away, you might be able to look at the angles of these things. You might want to normalize vectors. I don't know, you might... Is Green's theorem useful here? Try to think back. But I want to see from you creative solutions, clever solutions, and simple code. You should be able to do this pretty simply. Maybe 30 lines max. I'm not going to show you my answer. Sorry. Okay, so the next thing to do is put all those pieces together. You've already done almost all of the parts. Make a function that given this folder name, so given MATLAB _ data, or I'll have 2 other folders here that aren't named this. Given that folder name, you will read these MATLAB files, extract the vectors, save them as .mpzs. You will build a grid for them. You will visualize them. You will then assign vortex labels. So for a bunch of extra folders, be able to do this. Might be 3 folders. When I send it out, it might be fewer or might be more. But know that this is a very difficult, if not maddening, thing to do by hand. Okay, So now a change of pace, a little bit different question. Here, you're going to be doing data management. You've been given a sheet of information regarding, let's see, where was that at? Process data. You've been given a sheet regarding some samples. I think this one's the answer. So what they've done is someone has, in their study, done different runs with different parameters saved in this file with different labels. So this file name can be traced back to sample information where there's .csv files. And these have parameter numbers and the max and min value of these parameters, plus date times. So your goal, well, it can be read here, is to find whether labels 0 and 1, so these labels 0 and 1, are associated with, or correlated rather, to the max value of parameters. So does label 0 have on average lower values than label 1? And for what parameters is this true? So I want you to essentially give me the parameter with the largest difference in average max values between the two labels. Then the next thing you're going to do is you're going to format this in a way that's amenable to machine learning and statistical analysis. That means each row is going to represent one of these runs. So run number 0, but instead of file name, you're going to extract all the max values for these parameters. And your solution will look something like this. So I have a run number, and for parameter 0, I have the max. For parameter 1, I have the max. And so the entire run will be described on a single row instead of an entire CSV file. Lastly, I'm just looking over here. Lastly, what you're going to do is you're going to visualize the KDE distribution. Now let me go ahead and see if that worked. I think I probably threw an error there. Yeah, let me go ahead and run this entire file and show you what that is. Now, the tool you're going to want to use is Seaborn distribution plot right here. And so we can quickly look. If you have a histogram, this nice little best fit line, that's your KDE, your kernel density estimate. So I don't want the histogram, that can be cluttered. No, let's let that keep running. What I want is for each sample label. So if you're labeled 0, you'll look at all of the parameters for that sample and find their distribution. And if you're labeled 1, you'll look at all of the parameters for those samples and find their distributions. And you'll plot them on the same plot in different colors to see just how much those distributions overlap. So let's see if this is throwing errors at us. Permission denied, because I left all of my Excel files open. Don't save here, don't save here. If you guys are fast, you might see the solutions when I scroll down. And let's see. Let's do that. And this is what your result should look like. So here I have in red samples that failed, and in teal the samples that were a success. So you should be able to produce this in relatively small amounts of code if you understand pandas well. So this homework's going to be hard. You should get started, you should get emailing me questions, and you should start sharing solutions and talking with classmates as fast as possible. And I expect Friday will be busy. With that, Good luck, guys.